Welcome to the presentation of MDA 8.6.4. My name is Matthias Geckeler. At ITAS I am the Product Manager for MDA. In the present video I'm going to demonstrate the new features and improvements listed here. In the description below the video you can find jump marks to access a topic. I will begin with an enhancement for the replacement of measure files. When measure files are replaced, MDA has to identify clearly from the new measure file the signals used in the configuration. The criteria applied for this identification were reworked and enhanced in MDA 8.6.4. For illustration purposes, I have prepared some measure files. Also new is the direct replacement of measure files by means of drag and drop from the Windows Explorer. In my measure file examples, I've chosen as device information some ITAS locations as well as famous mountains. When a measure file is replaced, MDA tries to find in the new measure file a signal with the same name. But additionally, some meta information must match clearly. These are the device and the ECU information. In my first example, almost all signals could be identified clearly and were replaced accordingly. In the best case, the signal name and the meta information are identical. This is called a perfect match. But there might remain signals which cannot be identified clearly. Then these appear in the configuration in the so-called no-match state. This is the case if either no signal or multiple signals with the same name exist in the new measure file. Then you can still conduct a manual replacement. Let's see the replacing behavior of my second example file. Again, it contains two devices. But MDA is unable to map these automatically to the devices referenced in the configuration. Therefore, a new device mapping dialog appears. Here you can define the assignment of the devices. On the left side, the devices are listed which are available in the new measure file. In the table on the right, you can see the devices which are referenced by the signals used in the configuration. More precisely, these are the combinations of ECU and device. To define that a new entry is used for the replacement, it is sufficient to drag and drop it onto the line of the target entry on the right side. To correct an assignment, just drag and drop again to the desired target line. The symbol between the entries indicates that MDA will use the assignment for the replace operation. The new dialog supports an additional use case. Imagine a measure file which contains several sets of signals with the same names but from different devices. So far, a file replacement resulted in a large number of no-match signals. With MDA 8.6.4, you can now define how the devices shall be mapped. It may happen that there are more devices on the left side than you need for the device mapping. The plus symbol left from the additional device entries indicates the consequences. The signals from a new device will simply appear as new signals in the Variable Explorer. These can be selected and added to an instrument as usual. Here it is well visible that there are two sets of signals with the same names, and that these originate from different devices. It can also happen that there are more devices referenced in the configuration than you can find in the new measure file. Consequently, there remain some of the existing entries without a new counterpart. Then, after the mapping, not all signals can be replaced and appear in the configuration in no-match state. In my last example, MDA could already identify one device for the mapping. This is done automatically. We call this a perfect match. For a perfect matching device, no other assignment can be done. This is a current limitation because MDA would get into a conflict situation for the signal assignments. Furthermore, this example demonstrates that the entries for the ECU and device combination can be limited to the device. This appears if all ECUs are identical and would be superfluous for the differentiation. I'd like to add a comment about the current implementation. It is on purpose that the new dialog is rather simple and will probably not cover all use cases in the field. Please contact us in case you have examples which are not supported sufficiently. This allows us to enhance the device mapping dialog step by step and to support also more complex tasks in future MDA releases. The following section is about general enhancement for calculations in MDA. Since many versions, MDA supports calculated signals. To define a calculated signal, you must know the physical formula and how to enter it in the MDA. With MDA 8.6.4, a first predefined calculation is delivered. You can find it on the new tab named Functions next to the tab for Calculated Signals. Structure and handling is similar to the calculated signals. First, you create a so-called function instance and define a name for it. Next, you select the predefined calculation from the drop-down box. Currently, there is only one entry listed, but with the upcoming MDA versions, there will be more and more calculations available. The main advantage of the new predefined calculations is that you do not need to enter a formula. It is sufficient to assign to the expected inputs the necessary signals. Based on the measure data of the input signals and the predefined calculations formula, the defined outputs will be calculated. These can be more than just one. After saving a completely defined function instance, its outputs are available in the Variable Explorer. To get unique signals, the signal names are a combination of the function instance's name and the outputs. Additionally, for a clear differentiation from the calculated signals, the device field contains the term function. The new signals can be used like ordinary measure or calculated signals. Besides the predefined calculations provided by ETAS, the new approach allows to include your own calculations. MDA supports so-called functional mockup units, briefly FMUs, according to FMI Standard version 2. The respective FMU file must be stored in a defined folder. Further details and limitations are listed in the release notes. Currently, MDA supports only FMUs created with ASCMO version 5.8 or higher, but the interface will be extended step by step. At the moment, MDA must be started again after a new FMU was added. This will change with the next release. After the restart, the FMU model will be listed in the function library. As you can see, the FMU model name is not necessarily the same as the FMU file name. The model name as well as other meta information is given in the XML file model description, which is a part of the FMU file. MDA just reads the contents of the file as given. The selection of the FMU model and the assignment of the input signals is done as for the predefined calculations. Eventually, the outputs calculated by means of the FMU model are shown in the Variable Explorer. Please consider the current implementation as a first step. It shall be an opportunity to get to know the new approach and to try it out. To extend and improve the functionality with future MDA releases, your feedback is welcome. Next, I'd like to present the support of further format versions for label files. Label files are simple text files. They contain a list of signal names and optionally some few meta information. They can be used to reduce quickly the number of variables in the variable selection of Inca or MDA to the signals listed in the label file. You can create label files from MDA's configuration manager. Based on the node you select, the file contains the signal from an instrument, a layer, or the whole configuration. Simply use the context menu entry Create Label File. Since MDA 8.6.4, you can choose additionally from one of the format versions 1.2 or 1.3. Each label file format version supports the capabilities of the former versions. While the format version 1.0 represents a pure list of signal names, the subsequent versions extend the simple list by additional meta information. In version 1.1, additional raster information can be included. With version 1.2, support of so-called key variable lists is possible. And version 1.3 is capable to carry also device information. Moreover, the label file is structured to distinguish measurement signals, calibration variables, functions, and groups. It is clear that each information can be written into the label file only if it is available for MDA, for example as meta information in the measure file. In my example, I have only selected some measure signals. For these, the raster, device and function information could be taken from the measure file. Let's see how the label file can be used in Inca's variable selection dialog. After the label file was loaded, automatically only those variables are listed for which the signal name and the device information matches the label file contents. Also, MDA supports the usage of label files for filtering in the Variable Explorer. First, you add the label file to your configuration as any other file format. Label files are listed under a separate node of the File Explorer. Let's switch to the Variable Explorer. Here, an own filter category exists for the label files. Like in the other categories, a checkbox allows to activate a specific entry of a filter category. As you can see, MDA is using only the signal name and ignores other meta information from the label file. This is done on purpose, as you have more flexibility by selecting independently a specific device in the corresponding filter category. Eventually, the list of signals is reduced to those signals which match the signal name in the label file and originate from the chosen device. The topic which follows now is about an enhancement for reading and writing ASCII-based measure files. MDA 8 allows to define how to read and write ASCII-based textual measure files. This is done by means of INI description files. An example file in which all options are documented is part of the MDA installation. With MDA 8.6.4, a new option allows to activate an additional row for the device information of each signal. Preferably, it is used in combination with the existing option for the signal name format. For the MRF format, the INI file includes already the new option. If desired, you can insert the option also into your own INI files. The option is valid for reading and writing of textual measure file formats. I have loaded my example file already in Excel. As you can see, the device information is available in an own row. In case of a calculated signal, the corresponding field remains empty. This is because MDA has a no data entry for the device of calculated signals. For the output signals of functions, the device is set to function. This allows to distinguish ordinary calculated signals from function outputs. A small improvement brings a good opportunity to explain more about invalid samples. When looking at my example, you might wonder about the shown signal curve. Especially when zooming in, you might think that the data representation of MDA is not reliable. This is of course not true. It is rather a very specific situation in which MDA continues to show data as reliable as possible. Let's have a deeper look. First, you can see at the left bottom of the oscilloscope an icon. It tells you that for the drawing of the signal curves, reduced data is used. This means that the oscilloscope gets only a limited number of samples. As a result, the drawing of the curves is faster. Usually multiple samples fall on the same pixel column. When a connection line is drawn, the samples on the same pixel column cannot be distinguished. The identical representation will be given if per pixel column only the smallest and the largest values are drawn. With increasing zooming level, the number of samples per pixel column decreases. As soon as the icon for indicating the reduced data approach disappears, the oscilloscope gets all samples provided, and then usually all samples will be drawn. But my example is not the usual case. The measure file I am using includes a high number of samples which are flagged as invalid. Since MDF format version 4, an invalid flag is defined. It is used to indicate possible anomalies during recording. Invalid samples are ignored during drawing in the oscilloscope, simply because where would be the correct location for drawing them? Moreover, a single invalid sample causes that on the respective pixel column no sample at all will be drawn. This is for indicating the presence of an invalid sample. To sum up, the signal curve in the oscilloscope is based on valid samples only, and it enables to see whether there exist invalid samples. Another special effect occurs with calculations. Namely, if the input sample is invalid, also the output sample gets flagged as invalid. Especially for calculations across a time range, one single invalid sample causes that the results for the complete time range get invalid. Then, for an average or an integral calculation, no signal curve is shown after there was a first invalid sample. On the other hand, the calculated signals enable you to define the handling of samples with an invalid flag. A simple method is to ignore the invalid flags completely. Whether this makes sense is your decision. In general, the invalid flag will have a meaning which gets lost by this method. In my opinion, the better approach is to treat the invalid samples as not available. This is done by a so-called no-value flag. It can be set specifically for samples which have the invalid flag. But a sample can carry both the invalid and the no-value flag. Therefore, it is necessary to remove afterwards the invalid flag so that the samples are just flagged as not available. Eventually, you get a signal which has either valid samples or samples which are ignored if there was an invalid sample. Also, a sample which has a no-value flag will cause a gap in the signal curve. But this sample does not prevent the drawing of other valid samples, so the gap can be seen only on deep zooming levels when individual samples are visible. Moreover, samples with the no-value flag will be ignored in calculations. Instead, the former valid sample value will be used. Thereby, calculations across time ranges are possible again. After this more general explanation, I'd like to mention the change done in MDA 8.6.4. Invalid samples should be the exception in your measure files. Nevertheless, such samples might appear especially at the beginning of a recording. For example, if some devices do not provide samples from the very beginning. With MDA 8.6.4, such initial invalid samples are identified and get the no-value flag. This is done automatically as long as there is at least one valid sample at a later point in time. Finally, I'd like to mention an enhancement for the drawing of signal curves in case a signal does not provide continuously samples. As explained in the former section, when drawing signal curves in the oscilloscope, MDA is using often reduced data. This means that only the smallest and the largest value are needed. This results in a better performance when drawing the signal curves. This approach shows correct signal curves as long as there are samples continuously available. But if there are time ranges in which no samples exist, the problem arises which values shall be drawn across the gap. For discrete signals like booleans or enumerations, the detection of such gaps was introduced some versions ago. If a gap exists, the last sample value before the gap is fetched and used to draw the line across the gap. Now with MDA 8.6.4, the same approach is done for analog signals as well. One challenge was that the gap detection should not have a noticeable performance degradation. The second challenge was to allow also drawing of linear interpolated connection lines across the gap. But of course, it is your choice whether linear interpolated or a constantly interpolated connection line is more reasonable in such a situation. Finally, you can see here an overview of all changes done in MDA 8.6.4. For more details, please have a look into the What's New slides. You can find these, as well as further information materials, both directly in MDA 8 and on the ETAS homepage. Thank you for your attention and for your interest in MDA 8.